We are in the Halladie Building. It was built in 1918 by Willis Polk, and it is one of the first glass curtain wall buildings in the United States. AIA San Francisco has been in the Halladie Building for over 30 years, and we felt it was important to move to the ground floor to raise visibility and public awareness of architecture and the built environment in San Francisco. Our aim is to increase community engagement and the education of the general public around architecture. So one of the planned uses of the space is the community involvement, and Rockwell played a huge part in the acoustics and sustainability. This space is being renovated so that it lasts for several generations and is healthy for occupants and visitors during its lifetime. Inviting the public in gives us the opportunity to demonstrate what's possible through good design and leading by example as architects. Rockwell has been an exceptional partner, and they're leaders when it comes to educating building professionals. We all benefit from Rockwell's transparency around their product manufacturing process. In working with Adlin Darling Design, it was important for AIA San Francisco to select materials that were healthy and sustainable. The no added formaldehyde in the Rockwell products were very attractive.
You want people in a commercial space to be happy with their acoustic environment. So that involves to have it be quiet enough, because excessive noise is very distracting and annoying. Then you also need privacy, the ability to have private conversations. And so there are extraordinarily important issues in commercial buildings having to do with acoustics. The best way is to start off at the beginning of the project with a checklist. The owner says this is very important that we achieve. And once the checklist is created, then it's very easy to accomplish the objectives. The problems I see in buildings with poor acoustics is that issues get left on the sidelines. You have one or more acoustical problems as a result of that. So since acoustics doesn't require a building permit, no building permit review in general, it's easy to overlook acoustics because of the zealousness having to do with focus on cost or aesthetics or getting it done on time. The columns are set where they are, and then the architects had to fit the various rooms into the building structure. So that was a major challenge. For example, we're in the large lecture room. It has parallel walls. And so we had to design the acoustics in response to the architecture rather than optimizing the acoustical design for a room as you might in a new building. This is a concrete building, and with concrete buildings, they're superior to lightweight buildings. And so there are pros and cons with older buildings versus new buildings. The architecture put the acoustically sensitive rooms off the window wall. So had they put this room up against the traffic and had a picture window looking out to the traffic, this room would have experienced a lot of traffic noise. But because of the architectural design, they mitigated that problem. We were working very closely with the architect in the AIA to achieve their objectives. It was very much of a team effort. We had our vision, but we needed to work within the constraints that they had in terms of budget and aesthetics. Acoustics was a goal because everybody saw the benefit in having great acoustics. And what's interesting is with the old AIA headquarters, they had poor acoustics. They had a lot of complaints, problems, challenges when they would have meetings. And so they wanted to have excellent acoustics, but getting back to the budget issue, yes, we want great acoustics, but can we afford it? So that was the required teamwork necessary to achieve excellent acoustics within the budget and the schedule. From a sound absorbing perspective, we use a variety of sound absorbing materials in this room where needed. So in the entry area, for example, we wanted to control reverberation time so that when people are gathering in the space, they're not overwhelmed with the high levels of noise. In this room, we wanted to have excellent speech intelligibility. So we use that as our criteria in selecting sound absorbing material, and then also paying attention to reflective surfaces to eliminate echoes that can be very distracting. Insulation can be used for sound absorption, but the insulation that I have in mind for this project is within the wall. Adding absorption within the wall provided a noise reduction of 5 to 10 decibels. And so that's a noticeable noise reduction. It's very cost effective to add absorption within a wall to improve the sound isolation. Rockwool AFB Evo was used within the wall cavity to absorb sound energy within sound isolating walls of the type we have around this room. From an acoustical design perspective, we liked using Rockwool because it has excellent acoustic criteria and very good documentation for their products. So we were enthusiastic about using Rockwool within sound isolation constructions. The exterior layer of material in this room is sound absorbing. It's adjacent to gypsum board, which is a sound isolating material. And the gypsum board is attached to a metal framework, metal studs, which is the structure. Now, within the wall cavity, we have Rockwool, which absorbs the sound within the cavity as it builds up. Then on the outside stud surface, we have a resilient channel. And so the resilient channel helps dissipate the acoustical energy as it flows from one side of the wall to the other side of the wall. Then on the entry area, the exterior wall of this room, we have the wall finish. Now, along with what I've described, we have materials to seal the wall airtight, because sound leaks in a wall will allow excessive sound to travel. So we have acoustical sealant. We have the electrical outlet boxes also sealed to mitigate sound transfer. The architect wanted sustainability as part of the materials for the project, and Rockwool came to their attention, and they asked me if Rockwool would be acceptable, and I enthusiastically approved using the Rockwool insulation within the walls to achieve our acoustical design objectives. The U.S. Green Building Council has acoustic criteria. They're called LEED, L-E-E-D. And so we endeavored to meet the acoustic criteria set forth by LEED. And so there are these independent variables. The building needs to be quiet enough, so we need to mitigate mechanical equipment noise. The various rooms, like the room we're in now, the reverberation time needs to be controlled to meet LEED criteria. And then we have sound isolation between acoustically sensitive spaces. In addition, LEED sees the benefit in having sound masking systems in a building like this. So we have sound masking system, and that helped us meet the LEED criteria. For LEED, the reverberation time in a room like this and the other meeting rooms is 0.6 seconds maximum. So that's what we designed to achieve. And as a result of meeting that criteria, we have excellent speech intelligibility in the room. And the STC ratings vary depending on sound separation between rooms and whether there's wall plus door, etc. Because doors are obviously the weak link in sound separation. The project overall will be used to demonstrate excellent acoustical quality both for architects and their clients and students who are interested in learning about acoustics and learning about technology.